Hello everyone, this is Kitesh here. In this video, I'm going to go through question number 6 from the AQA 2022 Physics Paper 1 Foundation tier. This question is on the topic of energy. A student made measurements to determine the specific heat capacity of vegetable oil. Figure 10 shows the equipment used. So you have a joule meter, which is used to measure the energy. Right? So let me label that here. Right? Used to measure energy. A top band balance used to measure mass. Right? Electric heater to heat the oil. A thermometer to measure temperature. And a beaker to hold the oil. So the question is 6.1. Describe how the student could use the equipment shown in figure 10 to determine the specific heat capacity of the vegetable oil. So you are describing how you would do this experiment. Now, to find the specific heat capacity of vegetable oil, right, you need to think about the equation. If you look in the equation sheet, you'll find this equation. The energy transferred equals the mass multiplied by C, stands for specific heat capacity, and this triangle and this symbol delta theta is the temperature change. So if you rearrange this equation, C, or specific heat capacity, equals the energy divided by the mass multiplied by the temperature change. So if you want to find the specific heat capacity, you need to know how much energy is going in, the mass of the oil, and how much the temperature increased by. And if you use it in this equation, you can find out the specific heat capacity. So what would you do? You would add oil to the beaker and you would put it on the top band balance and work out how much mass the oil, weighed, right? What the mass of the oil is. And then you would put it on the electric heater. And now before you switch it on, you would measure the starting temperature. Let's say it's 20 degrees, right? And then you would heat it, let's say for about 10 minutes. And then switch it off and find out, leave the oil there and find out what the temperature actually increases up to, right? So it takes a little bit of time for the temperature to be transferred to the oil. So let's say it goes up to 60 degrees, right? And in that 10 minutes, you need to know, you can use the joule meter to find out how much energy was transferred to the oil. So using the joule meter reading to find the energy, top band balance to find the mass, and the thermometer to find the temperature change. Using those three equipments, we can find those three values and use it in this equation to find or work out the specific heat capacity of vegetable oil. So how would you write this answer here? Right? Right? Here's a model answer. Measure the mass of oil using the top band balance. Measure the starting temperature of oil using the thermometer. So let me write the starting temperature of the oil using the thermometer. Place the beaker of oil on the heater. Switch on the heater to heat the oil. Measure the final temperature of oil using the thermometer. Measure the energy transferred. The energy transferred using the joule meter. Calculate the increase in temperature, which is final minus the initial temperature. And then use the equation E equals mc delta theta to determine specific heat capacity, and I can add one more, right, bullet point to say specific heat capacity. It's not capital C, it's lowercase c, equals the energy divided by, let me copy that across, it's easier to copy the symbol across, divided by the mass multiplied by the temperature change. Now for the 6 marks, even if you write a couple of bullet points, the first couple of bullet points, what would you use these equipments for? You should get at least 3 of the marks. Question 6.2, give one risk when using the equipment in figure 10. So what is the risk when you're using some of the equipment? Well, you're using a heater which can cause burns or scalds. A different student did not have a joule meter and calculated the energy transferred by the electric heater. Use the equation sheet to answer the questions. Write down the equation that links energy transferred, which is E, power, which is P, and the time. So if you look in the equation sheet, you'll find the equation that links all 3 of them. It says power equals energy transferred divided by the time. Or you can write the simple equation, power equals E over T. Question 6.4. The electric heater had a power output of 50 watts. So that's the power. Calculate the time taken. So they want you to find the time taken for the electric element to transfer 4,750 joules of energy to the vegetable oil. So again, write the equation, power equals energy divided by the time. So 50 equals 4,750 joules divided by the time. So when you rearrange this equation, time equals 4,750 divided by 50, and that gives you an answer of 95 seconds. In a deep fryer, vegetable oil is heated by an electric heating element. Food is then cooked in the hot vegetable oil. The deep fryer contains an electrical component to monitor the temperature of the vegetable oil. Figure 11 shows how the resistance of this electrical component changes with temperature. So at 0 degrees, the resistance is 1000 ohms. As the temperature increases, what is happening to the resistance is actually steadily going down according to the graph. So what electrical component is used to monitor the temperature of the vegetable oil? Well, you would use an electrical component called a thermistor, right? So thermistor, and it has a circuit symbol which looks like this, a rectangular box and a line going through like that. That's a thermistor symbol. Question 6.6. The electric heating element in the deep fryer automatically switches off when the vegetable oil reaches a certain temperature. Figure 12 shows how the temperature of the vegetable oil changed after the deep fryer was switched on. So when it was switched on at 0, the temperature started, right? So that's 50 for 10 boxes again. So which means for one box, if I divide 50 by 10, that will give me 5. So here the temperature is starting at about 20 degrees. And as the time increases, the temperature also increases up to about 160. So that's 160 degrees. And that would be 3 minutes, right? So when it hits about 3.2, 3.3 minutes, the temperature has hit the maximum and it's not heating up anymore. So determine the resistance of the electrical component when the electric heating element automatically switches off. So when is it switching off? It's switching off when the temperature is 160 degrees, because it's not heating up anymore. So you'll have to use both the graphs. Use figure 11 and figure 12. So the maximum temperature that it's going up is 160. So if you go back to the previous graph, if you work out where is 160, well, again, each box is 5 degrees, right? How do I find that out? Because there's 10 boxes between 0 and 50. So if I divide this 50 by 10, I will get 5. So each box is 5 degrees. So 160 is over here on the graph. So if I draw a straight line up, it should meet at that point, and that's about 2.5 boxes up from 200. So that's 300 in between 200 and 400. So in between that would be 250. So the answer for this is 250 ohms. Question 6.7. Some chips were put in the deep fryer. In the deep fryer, water in the chips underwent a physical change and became steam. Why is this a physical change? So a physical change is when you can change it back to what it started off. So water is changing into steam, right? And if you cool down the steam, you will get the water back again. So why is this a physical change? All water can change to steam. That's not the reason. No chemicals are involved when water changes to steam. The change from water to steam can be detected visually, or the water will recover its original properties if the steam is cool. That is your answer. That brings us to the end of question number 6 and the end of the paper. Thank you for watching. I will see you in the next video.